red mouse cat. In this video, we're going to look at how you can tackle question 5 in your mathematics paper 2, which will most likely be based on grade 10 and 11 trigonometry. So starting with a simple question where you will be given a trigonometric expression or equation which is basic, with like a single trigonometric kind of equation, uh, and a simple right hand side, nothing complicated, no fractions whatsoever. The first thing you have to do in such kind of questions is to simplify the given equation, so that on the right hand side you have a trigonometric operation on your, then on your left hand side you have your angle, or the other way around. And then after doing that, try to make sure, or try to make the angle side, or the right hand side, the side which has the numbers, try to make the number a fraction if possible, if it is possible. And then try to make sure that the left hand side, which will have the trigonometric operation, has only the trigonometric operation, and if the angle is there, with the angle put there. And then the next thing you want to do is to use the given equation, or the simplified equation, to plot, to say, using the angle you just calculated and the right hand side, to determine the coordinates. And then how do you do this? You would remember to that if you would use SOHCAHTOA to say, if you have cos of x, and then in the other side you had a b over c, you would know to say the b is the adjacent side and the c is the hypotenuse. So that's how you get these coordinates. And then after getting the coordinates, you will now be able to answer the questions which follow. And in some cases, it will be also important for you to simplify the angle if you have it, so that it is an acute angle, so that it's easier to deal with. If you can't simplify it to be an acute angle, you have to be able to simplify it to be an acute angle. What I'm trying to say is that, if possible, make that acute angle to be a known acute angle, which we can get the answers to. For example, make it 30 degrees, 45 or 60, because we are able to get the trigonometric values of such kind of angles easily using this circle. Sometimes you might even have these things in your head. If someone says give us the cos of 30, you might already know it from your head, because you have been doing this from last year. It's now a standard procedure. And then now, after dealing with you plotting, if needing to plot, and you getting the special angles, if there is a need for such, you can now proceed to answer the following questions, which will be easy as ABC for you. And then in the eventuality that you face a question which is having multiple trigonometric expressions, making the numerator and denominator, those kind of questions will be mostly simplifying questions. What will be important there is to make use of the reduction formula to simplify the expressions to the fullest. Most likely try to make sure that the expressions look the same, they have the same kind of angles. You're simplifying for them to have acute angles as much as you can. And then now you proceed to now cancel out what can be cancelled out. And if possible, you just continue to simplify the expression to the fullest, using as much information as you can use. You can use also the cast diagram to assist where possible, to know if this conversion might need the sign to change, or if the reduction formula implementation might need the expression itself, the trigonometric function itself to change. If you are dealing with a 90-degree, mostly this cos will end up changing to be a sine in the process of you simplifying these kind of cases. So it's all about the reduction formula, getting to the acute angles, if possible getting to the special angles, and simplifying to the fullest. And once you have reached a point where you have no other options when it comes to simplifying that question, then you can now present the answer you have as the solution. show all steps to collect all points as much as possible. And then now the elephant in the room, when you are given a general formula kind of question. So how do you recognize a general formula kind of question? It's a question where you are asked to say, for which values of x does the given functions, um, maybe they ask you to say, for which values of x does the function given to you, maybe it's a sine graph with a tan graph, for which values of x do these um, uh, graphs um, intersect, and you find that the sine graph is below the tan graph kind of questions. So these kind of questions, because you would remember that the trigonometric functions run infinitely in your x-axis, you will have to answer them in a way that is dynamic to say when whether you are going to 700 degrees, x equals to 700 degrees, your answer must be still applicable. If you go to negative 800 degrees, your answer must be still valid. So that's when you know to say the answer has to be a general formula kind of questions. So it's when you are asking asked to give answers in terms of x which meet a certain criteria. So you start by determining what the equations of the graphs you are dealing with, and then you plot them if they are not plotted. And then after plotting them, what you have to do now, you have to highlight the, 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 the meeting points of the graphs. And if you have not done the calculations required to determine the meeting points, it's now time to do the calculations and then highlight those points. And then now you are able to now use the highlighted points to determine where and what where and which cases are we meeting the criteria. And then now you do what now, you after determining to say the criteria is met here, you try to see if there is a pattern in this criteria being met. If there is, you try to now document your answer using an equation that best describes that pattern. That's what you are doing in step number 5. And then in step number 6, you give them the solution. So let me make it a quick thing. Let's say they are asking you to say, please tell us, let's say the question was saying, please tell us where is, okay, what do we call, let's call this sinusoidal graph G. Let's call this G. To say they are asking you to say, where is G above 0 and G above F. They want you to tell them where is G above 0, so it's above 0 and it's above F at the same time. So you realize that that case is here and that case is here. You see that? And then now you realize, okay, this is from negative 180 to maybe negative 110, and then it's from 0 to again 60 there. So now you are able to tell, okay, from this point to that point there is a distance of how much? There's a distance of 180, and then from this point to that point there's a distance of 180. So now you are able to tell them to say, for the first thing, x is changing, to say x is something that is equal to negative, is equal to 180. That's you telling them how these 2 points relate. It's 180 times k, where k is an element of real numbers. That's how you get a an answer for such points. And then you can tell them about that, those points again, to say we have these points which are what, these points which are 60, which are 60. It's okay, it's 60, it's 360 plus 60. It's not 360 plus 60, it's Let me calculate in my head. Okay, it's 360k plus 60. It's 360k plus 60, where k is an element of real numbers. So x equals to 360k plus 60, where k is an element of real numbers. And then now that's you determining the points, and then you join it to make it a region to say, okay, the criteria is met when x is between those 2 points. So when x is between 180k, 180k. This was a complicated one I just made up in my mind, but it's a nice example. X is between, and then 360k plus 60 plus 60, and then you add to say k is an element of real numbers. And that's how you, not element of real numbers, you can say an element of integers. I forgot what do you use when you want to say element of integers. It's not this one. I think it's Z. It's been 5 years ever since I did this. So yeah, element of integers, and that's how you answer a, what do you call it, a general equation kind of question. So it's all about trying to represent everything in a pattern kind of way, and then you present the solution at the end. And then when you're dealing with the proof kind of questions, so it's always important to do what? Deal with the complex side and try to make it look like the simpler side. So you are proving that the it's a matter of simplifying, to say if you simplify the complex side well enough, you will end up making it look like the simpler side. So what do you do to do this? You start by simplifying also the simpler side, so that it's at its simplest form. And then now you can now proceed to tackle the complex side. And you tackle the complex side using double angles, you use your identities, you use your reduction equations, and you use the perfect angles to simplify your complex side. And then you simplify until the simplified side is equivalent to the simpler side. And then at the end you write the statement that I have proven that the left hand side is equal to the right hand side. And that's how you do that. So for example, here I see a double angle. You will want to um, try, okay, this is not a double angle, but okay, whatever it is, you know best. I see there might be an identity somewhere here, because I see something like that there. And this is, if this is fitting an identity or double angle kind of thing. This is not an identity. I thought it's an identity from a distance, but you know how to tackle this thing best. So you use the guidelines I gave you there. And in this question, I would say which one is the simpler side here? I would say this one is the simpler side, because when you simplify using the identity, this will be the simpler side, and then you will tackle this as the complex side until you make the complex side look like the simpler side. And that's how you basically answer your what do you call them? That's how you answer your grade 10 11 trigonometry in your mathematics paper 2 and collect maximum points. Thank you.